Greetings, welcome, and thank you for viewing today's PATCHMASTER 101 classroom session. My name is Ed Buck and I'm the event host. This presentation is focused on giving you a high-quality overview of the PATCHMASTER user interface and to orient you to its capabilities and methods. Our speaker today is Dr. Frank Elson, who is one of our experts supporting the EPC line of amplifiers and of the PATCHMASTER software. With this being said, I'd like to hand the microphone over to Dr. Elson. Frank?
Thank you, Ed, for this great introduction. Thank you. Hello and welcome to the webinar on PATCHMASTER Basics. My name is Frank Elson, and I'm the EFIS Application Specialist at Harvard Bioscience. Now, the purpose of this webinar is to introduce you to the very basics of PATCHMASTER. This is the HEKA acquisition and analysis software. Please note that I will not go into every little detail of the software or explain every knob and display. But to practice, you could download the software later from our website for free and install it and run it on your computer. To do that, you do not need any dongle or any hardware installed. You can run it simply in demo mode and you can play around with it a little bit. And while you're at it, I would also recommend to download the PATCHMASTER manual. There's lots of useful information in it. With that, I would like to get started. Now, this is a brief overview of the PowerPoint presentation. And I will start off with an overview slide that explains a little bit about the handling and the workflow in PATCHMASTER. Then a brief introduction about the installation procedure, which is pretty straightforward. Then we will talk about a couple of different windows of PATCHMASTER. Each window has its own purpose and function. And we will get into those in a minute. I will finish the PowerPoint presentation with an overview slide that demonstrates how to record, display, save, and analyze data with one click. Now, the handling and the workflow in PATCHMASTER. In the middle of it is, of course, are you basically the scientists. You have to work with PATCHMASTER to do your experiments. And for that, you have a manual control. And basically, PATCHMASTER windows can be categorized in two main categories. One is the parameter window, which has an input and readout, and the other one are information windows that only give you information or readouts. Today, we talk about the windows shown here in blue. From the parameter windows, we of course discuss the amplifier window, the pulse generator window that allows you to create stimulation sequences. And we will talk about the control window and the online analysis window. There are more windows, more parameter windows in PATCHMASTER, but I will not talk about them today. The other type of window in PATCHMASTER is the information windows. And today we talk about the oscilloscope window, the notebook, and the replay window. Again, there are two more information windows, but we don't talk about that in this presentation. One very important window in PATCHMASTER is the protocol editor. It is a special window. It cannot be categorized in either one parameter or information window. It is more like an assistant to you. And what the protocol editor does, it controls the other windows. And you can, of course, control the protocol editor by writing a protocol or a script, which basically gives you automatic control over all functions in PATCHMASTER. And you always have, of course, manual control at any time. This brings me to the installation procedure. The hardware installation is very straightforward. You basically plug in your EPC10 or your EPC800 USB amplifier, and the computer will automatically recognize the hardware and install a standard driver. And then your hardware will show up like this. The second thing is that you need to install a the protection key for your software. And to do that, you have to download the driver from our website, install the driver, and then just plug in the protection key. And then it should light up like this. And if that is the case, that means your protection key has been recognized by your computer and it's fully functional. The third thing for the installation procedure is, of course, the software itself. You can download usually two different versions from our website. And the important point here is that we have very often a version that is proven to be without any bugs and without any hiccups. And we have a more newer version that has already newer features included in it. Has newer features included in it, and but might have still some bugs present. So either version is usually fine, and you can download it, of course, for free from our website. Then after the installation, you will find a HEKA folder, and inside the HEKA folder is a PATCHMASTER folder. And that PATCHMASTER folder has several files, of which we will talk about in a minute. The most important one is, of course, the exe file, the executable file from PATCHMASTER itself. And then there is another file which is called patchmaster.set. It's a configuration file, and we will talk about this in more detail during the live demonstration. Then there are other default files which are also important, and we'll talk about them as well during the live demonstration. This brings me to the graphical user interface. Basically, what you need to know is that the graphical user interface is made up of different windows with different functions. And all those windows can be changed in terms of color or text, and these changes are being saved in the PATCHMASTER set file. Now, this is, for example, how a typical graphical user interface could look. And I would always recommend to have these windows open during a recording. These are the windows that give you full control. Of course, there are other windows that are important, but I would then open them when you need them. For example, the pulse generator, which is, of course, important for you to change maybe a stimulation sequence while you are recording, or while you are in the middle of an experiment. So you can open the protocol or the pulse generator window, change your settings, and then execute the new settings with the control window. We get into this in a minute. Then we have on top of this window here the main menu. And there are a couple of buttons important. One of the more important ones is, of course, the Windows menu. So when you click on this, a drop-down window opens up, which allows you to open and close different windows in PATCHMASTER. And I would like to get started now with one of the more important ones, which is, of course, the amplifier window that controls the amplifier. Now, before we get into this, three things that I would like you to remember here. One thing is that the amplifier that can be controlled by PATCHMASTER with the amplifier window are the EPC9 amplifiers, EPC10 line, as well as the EPC800 amplifiers, plus the ITEF90, which is the 2-electrode voltage clamp amplifier from HEKA. In addition to that, I would like you to note that you can also you have limited control over amplifiers like the EPC7 and EPC8, as well as the AXOPatch 200B and Warner amplifiers. Important to note here, for this limited control to work, PATCHMASTER needs to have the amplifier to have telegraphing outputs. What can you control? Well, basically everything. In the EPC9, EPC10 and EPC800 amplifiers, you can control the whole amplifier, of course. In the other amplifiers, it's very limited. Mostly gain and filter settings can only be controlled. The third point is that you should note that the protocol editor has full control over the amplifier window. which of course helps you to use this automatic features that you can run an experiment with fully automatically. Now on the upper right hand side, I want you to note that there is a little logo now displayed. It shows that this amplifier window is one of those parameter windows in PATCHMASTER. And this is how an amplifier window looks. It has all kinds of controls, but before I get into those different controls that it has, I would like to introduce you or would like to show you what you could do. This is totally optional. What you can do is you can change the background colors and the font settings of each of those little boxes in the amplifier window and in all the other windows. And this is basically how I do it, or how I like to do it. I use a different color coding for the function of the window itself. And I will get into this more during the live demonstration. But applying this color code to this window would change the window to something like this, for example. Now on top, you have three options for how to display the window. If you choose monitor, then the window is being very small, and you only have very basic functions that you would need maybe doing an experiment to change gain and membrane potential settings. And you have, of course, the display settings of the amplifier. Then the middle part is the one that I like to use best, is the tuning function, which we will discuss in a minute. And then the show all button basically shows you the entire list of all the functions available. And I will not go, like I said in the beginning, through all of those, but one little function I would like to mention here, which is a very good function, very nice. It's the gentle CC switch function. And this function enables you to switch between voltage clamp and current clamp without any big bumps, I would call it. So basically what it does is, if you, for example, switch from a voltage clamp mode to current clamp mode, and you switch from minus 60 millivolt holding potential and voltage clamp to the current clamp mode, doing that switch, what happens is that the amplifier injects the correct amount of current to not change the membrane potential at the moment of the switch. Yeah. So this is of course very nice, and it prevents you losing the seal when you make the switch. Now, let's see what else we have here. This is, for example, the upper left side is the upper left corner. It's the gain settings. And when you click on it, as you can see in the red background already indicated, it's a drop-down window. You click on it, it opens up. And here you can select basically the different gain settings. Important for you maybe to note here is that depending on the gain settings, a different feedback resistor will be used automatically. Yeah. Then we have on the right hand side here, this is where the membrane potential is being set depending on the recording mode. Of course, if you're on voltage clamp, you set the holding potential. If you're on current clamp, you set the holding current. And then underneath it, we have an area that I call the display area only. And again, depending on voltage clamp or current clamp, you have different displays here. In a voltage clamp, the left box shows the injected current. And in current clamp, the left box would show, of course, the holding current that is injected. The middle box is the holding potential in voltage clamp, or the current, the membrane potential in current clamp. On the right-hand side, this box is something that is kind of important, doing many things like establishing the recording configuration. It shows you basically the different resistances that can occur during your recording configuration. And here it depends on what kind of mode you will be in. For example, if you have an open pipette in the bath, this will show you the pipette resistance. If you are in cell attached patch configuration, then this will show you the seal resistance. And if you are then in the whole cell configuration, this area will show you the membrane resistance. So you would need to know in what kind of recording configuration am I at the moment to know what resistance is displayed. Then we have underneath the auto buttons, which I will talk about in a little bit in more detail. These auto buttons can be used to control the amplifier window when you establish the recording configuration. And they can also be modified and adjusted to your liking, basically what you like to have them do. And you use the protocol editor to do that. And I will show you how to do this in the live demonstration. Underneath it, we have a couple of buttons, for example, the wholesale or this recording mode button, which is a drop-down window. As you can see, when you click on it, you can now select the different recording configurations, as well as you can select current clip. Then underneath it is an area where you can change the test pulse, or where you can control the test pulse. And we will go into much more detail about the different functions here in the live demonstration. Underneath it is the area where you can set the liquid-liquid junction potential, and where you can execute the automatic offset control of the, or where you can basically start with an auto offset compensation to compensate all the offsets in your setup. Underneath that, we have the C-fast compensation. Here you compensate pipette capacitance. And again, during the live demonstration, I will show you how to use this. Underneath it is the area for cell capacitance and series resistance compensation. Again, later during the live demonstration, we will use it in more detail. And then the last part is, of course, to set the filter frequency of your recording. This brings me to the oscilloscope window. Two things I would like you to remember here is, one, it displays the live current response, of course, to either the test pulse or to a stimulus sequence. The second function of the oscilloscope window would be that it displays the data traces of, it displays the current response of a data trace that has been recorded earlier. And on the upper right hand side, please notice there's this little red logo now that shows an eye, which indicates the oscilloscope window is an information window and not a parameter window. You can open it, if it should have been closed, with pressing F12, or you can, of course, go to the Windows menu and select it from there. This is then how the oscilloscope window would, for example, display the test pulse. Important to note here is, when you're in the test pulse mode, you will see on the upper left-hand side, there is no display of any data file. And this means, this indicates to you, okay, I'm now in test pulse mode. Why would that be important? Because it reminds you that these functions are not functional. Yeah. So when you're in test pulse mode, you have to remember that you cannot change any scaling inside the oscilloscope window. When you open a data file, these buttons that are non-functional during the test pulse become functional, so you can use them, and the functions are pretty straightforward. First of all, you see on the left-hand side that the data file, where the data file is located in your data tree, is being shown here on the left-hand upper corner. And then these buttons have functions that I don't go into detail now. Just to summarize them, the top buttons are being used to analyze traces and to reset the display. And on the right-hand side, the buttons can be used for scaling and display purposes as well. And I will show you later in the live demonstration a little bit how to use them. Then, in addition to that, together with those buttons, you can, for example, press on the display button in the main menu, and this gives you additional functions for the oscilloscope. And again, I don't go through all of those now, just to summarize a couple of things, a couple of functions. You have here, you can specify trace properties, you can already analyze some of the data. General display settings can be changed here, as well as scaling settings. Important to note here, I want to make that point again, is that I would strongly recommend to download our PATCHMASTER manual from the website, and every button is explained in detail in the manual. This brings me to the next window, the replay window, which is also an information window. It has three functions. Data, of course, being stored here and can be accessed from this window. And the data is organized in 5 levels, basically, which I will explain to you in a minute. And then the other thing is that the raw data are being stored together with analyzed data traces, or for example, also with leak traces. You open it with F10 or select it in the Windows menu. And this would be how a replay window would open after you press open. There are no data displayed. You have to basically open the data separately. And if you open a data file, this is basically how it would be displayed. And here you see already the organization of those 5 levels. The very first level is the root level. And this is basically, I would say, or call it maybe the experiment level. You can change the label of it, and you can change a text that you can actually link to this level, which I also will demonstrate in the live demonstration. It basically is the uppermost level, and you can call it whatever you want to, of course, but I call it basically the experiment level. Underneath it is the level of the group or the cell level. For example, you can, while you're doing an experiment day, you can, for example, call each cell that you record cell A, cell B, cell C, and so on, whatever you want to call it. And for each cell, I would, for example, create a new group. Inside the group is then the series level, which is basically all your stimulation sequences. Each stimulation sequence can, of course, have multiple sweeps. Yeah, like in this case, an IV step protocol has multiple sweeps, whereas a ramp protocol maybe has only one sweep. And then the last level is that each sweep can, of course, have multiple recordings. You can have, for example, the current trace being recorded as well as the voltage stimulation trace in this case. Then the top buttons actually show the control for managing and the display and selecting data traces. And like with the oscilloscope window, you also have the option to press or open up more functionality by selecting the replay in the main menu. And here again, just to summarize a couple of things, you have many different functions available. For example, you can actually check the PGF file info, which is basically the information of the stimulus sequence that was used to create your data, which is a very helpful function, of course. You can export and import stuff here, and you can already do some analysis as well. I would like to point out one thing. To create a new group, like I said, or even a new experiment, what you do is, it's very straightforward. You go to the File in main menu, and then you can create a new group or a new experiment simply by pressing the button, the respective button. This brings me to the pulse generator window. It's a parameter window where you can enter stuff, but which also gives you information of the file itself. So you can also see information in that window. There are 3 things I would like you to remember here. You can basically create a stimulus sequence, any kind of stimulus sequence available, a huge amount actually we have available. And then the second thing is that in the pulse generator window, there is a pool of all those stimulus sequences, which can be, of course, saved in one PGF file. So what you could do, for example, you could create a pool of stimulus sequences for one project and save it in a specific PGF file, and then open that PGF file when you do experiments for this specific project, so that you don't have all your files at all the time. That would organize it a little bit. The third thing that is important here to note is actually that this pulse generator window provides a link to the online analysis window. And this is something I want to show you in a minute, which is a very powerful tool and function. And these are the three things that you should remember from the PATCHMASTER pulse generator window. Again, you open it with F8, or you can select it in the Windows menu. And this is how the pulse generator window would look under full view. The other two views I don't discuss now, just reduced views basically. The full view is really what you want anyway. Okay, and we have a couple of different areas here, different buttons. And each area here is briefly explained. So the upper part is basically where the pool of stimulus sequences are located. You can select them by simply clicking on the specific sequence. And underneath it is an area where you can change how many sweeps you want, the acquisition frequency, and all other kinds of little things. Again, in the manual, each little button is explained very nicely. Underneath that is the area where you can select what kind of stimulation channels you would like to use and what kind of recording channels you would like to engage. So, and this is an area, especially for the recording channels, that I will mention in a minute in more detail. Underneath that is the area where you can set the shape and the size of the stimulation sequence. And we will show that during the live demonstration, what we can change and where we can change it in a minute. Then this is one point I would like to actually make specifically very important. There's this little checkbox. It says store. Now, here is an important point. If you do not check this, or let me put it this way, if this checkbox is not being checked, then the data trace is not being recorded, and cannot be saved. So there is a fail-safe device built into the control window, which I will show you later, that when you do your recordings and you can see with one look at the control window if the data trace is being recorded or not. I will also show you later in the live demonstration a feature that also should alert you immediately if your data trace has not been recorded. Okay, so this will come in a minute. And this is the link. Here you can link the online analysis, or you can link this, the stimulation sequence to the online analysis. And we will do this as well during the live demonstration. This brings me to the analysis window. Again, a couple of things, three main points that I would like to make. The online analysis is basically that you can record a data trace, and while you are recording it, an analysis is being done already. This also works, of course, offline. The second point I would like to make is that you have a vast amount of analysis functions available. And we will not talk about them all, but I will show you in the live demonstration how you can actually use the online analysis and also show you where you can select all those functions. And then the third function, or the third point I would like you to remember here with the analysis window, that it is also possible to analyze data after they have been recorded. And you can use basically the same way than what you would use for the online analysis. You open up the analysis window by pressing F7. And important here to note is, if you look on the right-hand side, there is a little window underneath the analysis window that says Analysis Window 1 and Analysis Window 2. These are actually the display windows of the analysis. So if you do an online analysis, to see it, you would have to open up the analysis window as well. Okay, and this is how the analysis window looks to set the methods basically of the analysis. The top button is being used as on and off switch, basically. And I show you how to do this. You can set it to no analysis, then no analysis is being performed, or you can actually select the analysis method, where the analysis method is located that you would like to do. And that would then set it to on. Underneath it is the pool, basically, of analysis methods that are available. And you can simply select it by clicking on it. When it becomes dark red, that's the analysis method that is at the moment selected, which can be then changed or modified. And you can modify it underneath by selecting different functions for this specific method. And then each function can also be changed. And by clicking on this little change button, you can then select a different function, for example. And this is now the overview of all the functions that are available. And then if you select the function, you can, of course, specify these functions in more detail. What exactly would you like to have the function do, basically? Underneath that is the area for the graphs. And this is pretty straightforward. You just specify the display of the parameters, how you want to have the parameters that are being analyzed being displayed in a graph. This brings me to the protocol editor. And again, three things I would like to remember here. It allows the user fully automatic control over the entire experiment. And this is done by writing a script or a protocol. Saving the settings allows the user also to replicate experimental conditions very precisely. So basically what you can do here is you write a protocol, and by then executing that protocol, the PATCHMASTER will guarantee that you will replicate your experiment exactly the same way every time. And this, of course, helps you to, for example, compare data between two different users, for example. Because if they use the same protocol, they will have been doing the experiment the same way. And this is basically the third point. The third point is that you can write a protocol and you can actually exchange it between colleagues, or if you have undergraduates or graduate students or beginners basically that just started to learn how to patch and how to do experiments, that is very helpful for them to not have to deal then with all the fine-tuning of an experiment. You can basically give them the protocol file and they can do the experiment exactly like it's supposed to be done. The protocol editor is opened up by pressing F9. And this is how the window would look, for example. It's a very straightforward window, not very complicated. The top row is again the pool of protocol files. You see already there's this common theme of all those windows. They are built up more or less the same way. So it makes it easier for you to learn basically how to handle those different windows. So the top row again is a pool, in this case of the protocol files. Underneath it is an area where you can enter and modify the commands on the left-hand side. And I will show you by changing the auto buttons in the amplifier window later during the live demonstration, how you can actually change and modify a protocol. In addition to this, I want to quickly point out you can insert those commands by pressing either button, insert before or after. And when you press it, then a list of events will pop up. And this list of events is huge. And I would recommend, for example, when you're in the learning phase, just learn one command at a time. And when you understand it completely, then go on to the next one, or basically use only the ones that you really need. And this is how you make your way through this list of events. Then the last window I would like to talk about right now is the control window. Again, 3 points that I would like to make. It provides you easy access controls to basically steer your experimental procedure. It gives you also information on the status of the current experiment. And the third point, which is really important, I think, and which I will show to you in the last slide in a minute, is that you have very easy activation of either stimulus sequence or protocol scripts. The control window, if it is closed by accident, it should be open all the time in my opinion. You can reopen it basically by pressing on control window here in the Windows menu. This opens then the control window, and this is how it looks. And it's very straightforward, and nothing too difficult to explain here. On the left-hand side, you have a box that basically gives you the status of the current situation in your experiment. For example, if you're recording, it will say acquire. Then next to it is a timer that shows you the time of the day in 24-hour clock. Next to that is the timer that basically shows you how long PATCHMASTER has been running. And you can set that, of course, to 0 by pressing the set buttons. And on the right-hand side, there are a couple of buttons that you basically press and use to start and stop experiments. Then the row underneath is the row with the stimulus sequences. And here you basically press just the stimulus sequence. When you press it, it will start. Underneath that is the row with the protocol scripts. And the same applies here. When you press on the button, the protocol will start. Now, this is also very nicely explained in the PATCHMASTER manual. Again, you can download it from our website. Now, this brings me to the last slide of the PowerPoint presentation. I would like to quickly show you how you can now record the data, display the data, of course, save the data, as well as analyze the data. And all you need to do is press one button. Now, here's our control window. And to start the recording and display and all those other points, all you need to do, like we said before, you press the button. And if you do this, for example, in this case, it's a step protocol that is called IV demo. So if I press this button, the step protocol will be executed, the data will be stored automatically. And while the data are being executed, the analysis also will be displayed at the same time. So this is basically a very straightforward, very easy way to get your data and the analysis in one press of the button. Now, I mentioned before that I would like to show you the fail-safe button. So here you see a store button that is dark red. And if this store button is dark red, that means your data will be saved. Yeah. So if you, for example, would like to do a step protocol quickly to just check something, but do not want to save the data, you can click this button and it becomes pink. And then the data will not be saved. And I will show you in a minute how this is actually done in the live demonstration. Now this brings me to the last slide. It's an overview slide of the following live demonstration now. I will show you quickly a couple of things, maintenance stuff. I will talk about the PATCHMASTER set file. This is an important file, and I will show you a couple of things that you should know. Then there is the way, for example, that you can reinstall the default settings and hardware selection by changing the PATCHMASTER set file, and I'll show you how to do this. Then we will establish a hoster configuration using the manual control of the amplifier, and then I will use right afterwards the auto buttons and show you how to do also use the protocol editor to basically fine-tune the approach. That will be followed by sample recording of using, of course, the model cell in this case. We will create a stimulus sequence, we will do experiments, and we will also then display the data, which shows you basically how to adjust the oscilloscope and stuff. And the last point will be about exporting the data traces. And the easiest way, in my opinion, is to simply copy-paste them into any, for manuscripts or for PowerPoint presentations. Okay, this concludes the PowerPoint presentation. and I would now change to the live presentation. For that, I will have to share my screen, which I do now. Okay, now you should see my screen. This is now the start of the live demonstration. And first I would like to point out basically, here you can see already that the hardware is being found. Yeah, so here you see it looks like a flash drive. When I click on it and right click on it, I can show you basically, look, it looks like a flash drive, the HEKA LRH88, but as you can see, you do not have write access to this. Yeah, it's not a flash drive to this drive. So this is an important point for you. What do you need to know when you install your hardware and you see the HEKA LRH88 showing up like this? This means computer found your hardware and it should be able to communicate with your hardware. Okay, then this is basically how the PATCHMASTER is installed. You will have a PATCHMASTER folder with all kinds of files inside, and I will go into those in a minute. Now, when PATCHMASTER starts the first time, it will look like this. This shows that the EPC is now started, and it will take a minute or two because there are lots of tests being done. So it tests the whole hardware and makes sure that everything is fine. Then this little welcome window pops up, which you can close by pressing quit. And we can also disable this little welcome window, which I will show you in a minute. And now you see here already the main windows that we think are important. Here's an analysis window that we can close for now. We don't need it for now. And this is the notebook window. I like to move it actually over to the right. It's good to have it open because it will show you lots of information. Then the replay window, maybe not in the middle, on to the right. Later on, we show the data in it. And then what I like to have in the middle is basically the oscilloscope window, because this is basically where the action is. And then you have, of course, the amplifier window. Test pulse off for now. And in the amplifier window, I like to have the tuning view. You can, of course, go to show all, but a tuning view should be fine for most applications. And here you can now change, for example, the background color of those buttons if you want to. And this is now what I show you right now is basically completely optional. You can change it or not. It's up to you. I just want to show you how to do this. Okay. So let's say you would like to change the background color of this box here. What you need to do is you go to Windows, you go and enable icon configuration, and now you move your mouse pointer over the box that you would like to change. You press and hold down Control and left click opens the configuration window. There's lots of stuff you can change. For example, the background color. So you go on background color, you change the background color to anything you would like to do. You say OK, done, and the background color is changed. Other things that you can change, for example, are the writing in those boxes. You can change the writing in those boxes. For example, let's change the writing in those auto buttons. Again, you go into the button that you would like to change the writing, the text basically, left control, and that opens up the configuration for that button. And now, for example, this is the setup button that usually when you press it does automatic compensation of the offsets. Yeah, and this is done, of course, when the pipette is still open inside the bath. So I personally would like to call it open pip, open pipette. Yeah, then I know this is when I press this button, the pipette actually should be still open in the bath, not being blocked by anything yet. And the same is also true. You can change, for example, this if you want to change it. It says seal. This is the seal button. You press it after you established a seal. But that would mean it's already the cell attached patch configuration, in my opinion. So you can call it, of course, already by its name. You can call it cell attached patch configuration. But again, this is completely optional. You can leave the names. The functionality doesn't change by changing the name. Okay. Now you want to save these functions, and I want to quickly show you how to do this. So for that, I want you to also look here in the folder. In this area here of the folder, you will see in a minute a file appearing, a dialog file. So a dialog file is a file that saves all those changes that you made inside PATCHMASTER for in terms of font and text. And again, you have to go to the Windows, and here you say Save Font Dialog. When you press it, there's the dialog file that just appeared on the left-hand side. Okay. And now, when you start PATCHMASTER, it will look for the dialog file. If it finds one, it will take whatever is written in the dialog file and apply that instead of the default settings. To save those, like I said, you press on Windows and you press Save Font Dialog. Okay, now I can close PATCHMASTER and just want to demonstrate to you what you can do to re-establish the default settings. Yeah. So if you save and exit, these changes that have been made are being saved in the PATCHMASTER set file. If for some reason you are not happy with it and you would like to go back to the default settings, what you need to do first is you have to hide or rename the PATCHMASTER set file. And you do this, of course, by either renaming it to anything you want, or this is why I created this hidden files folder here. You can create a folder like this if you want to, and you can just grab it and move it up there, and then it's being hidden. And now if you start PATCHMASTER exe, it will start with the default settings, or it will allow you to start with the default settings. I will also delete now the amplifier idea file, because this is something I don't want to have for later when we show in the live demonstration. I don't need this now. So if I now start PATCHMASTER and I use the same shortcut, what happens is it will come up with a message that looks like this. This is a warning message, not an error message. It says configuration file not found. Yes, of course, we don't have the patchmaster.set file, which is the standard file PATCHMASTER looks for, is not here anymore. So that's why it can't find it. And now I can tell him where it is, or I say set defaults. Now PATCHMASTER will start with the default settings. However, before it does this, and this is an important point, if you should have ever trouble with your hardware that the hardware cannot be found, this would be something I would do. I would hide the PATCHMASTER set file, start with the default settings, and then it allows you, before it starts, to find the correct hardware. With the EPC10 USB amplifier, there is no need, it finds it all the time correctly, and you only have to have this little button here enabled. This means that the EPC10 USB amplifier is being found or will be found automatically. If you disable this, it allows you now to basically go and look for it yourself, basically, which I wouldn't recommend. As long as it's a USB, it will find it automatically, so leave this enabled. This is also true for the EPC800 and for the other amplifiers. So one other thing I would like to mention here is a little gadget, maybe, if you want so. You can actually go and look how does the amplifier window look in PATCHMASTER for other hardwares. And what you could do here is to check it out, basically. You could, for example, select the hardware that interests you. Although it's not connected, PATCHMASTER will allow you to start in the demo mode with this other hardware. And you can select it, press continue. At that moment, of course, since we do not have an ITEF90 connected, the PATCHMASTER will tell you that there is no ITEF90, but you can still continue. And then PATCHMASTER starts in a way it would start with an ITEF90 being connected to it. So the welcome window we can close again. And this is basically how it would look. Yeah, this would, for example, something to just play around with. if you want to. Okay, now let's get to the real stuff. I close everything and don't save anything. So what I'm going to do now is, first of all, I would like to use a dialog file that I created earlier. It's inside my hidden files folder. Here's the dialog file that I would like to use with the font and color settings that I like. So I copy this and put it into the PATCHMASTER folder. This is completely optional. Like I said before, you don't need to have a dialog file to run. It would then run simply with the standard fonts and colors. Okay, so this is done. Now I can start my application by using a different set file. And this is, for example, something that you should consider when you have multiple users using the same computer. Yeah, I would recommend that each user makes their own set file and then create a little extra shortcut, something like this, for example. Show you the properties of the shortcut. In this case, this shortcut points to patchmaster_demo.set, basically to this set file. So what happens now is, instead of using the patchmaster.set file, Patchmaster will start using this set file. And you can, of course, rename it to anything you want. So if there's different users, you can call it whatever you want, and the user just creates a shortcut which points to their set file, and then you do not mess with any other people's settings. Okay, so and this is how it's done. You start it, and then it initializes the EPC10. Again, these are tests which are every time Patchmaster starts the EPC10 hardware, everything is being checked. And here you can see now the set file that is being used. It also tells you in the notebook down here exactly what's happening. The dialog file amplifier dir has been loaded. Yeah. And to go and check on the set file, you can go on Windows, Configuration, and here you see also up here patchmaster_demo and not patchmaster.set. It's patchmaster_demo.set that is being used. The configuration window is one of those windows that I don't want to talk in too much detail. It gives you lots of access, hardware access, for example, things that you can change, files or pathway, a path to different files can be changed here. All other kinds of things are being able to be changed in this. And you can save it. Like I said, different names with save as, for example, you can change it to anything you want and then save it to that name. And the next time you start it with that set file, it will be with your changes. Yeah, this is an important point. If you just want to save whatever Patchmaster is shown here, you press save and it saves it into whatever is being loaded. Okay, but that's it. Now let's get started and patch a cell. And we want to do this first with the manual control. And we do manual control. Okay, so what we're going to do is the following. We have a model cell connected to the head stage. And this is now what we're going to do. The first thing is, of course, when you have a cell or pipette in the bath, you want to compensate for the offsets that are in your setup. And I would recommend here this little blue box, in this case blue box, is where you enter your liquid junction potential. This is a very important thing. Okay, so let's say our liquid junction potential is -5 millivolts. So what I do is I enter it, -5, yeah, return. And then I can press the auto button to compensate for this liquid junction potential. And you can see up here it has been taken into account. So the next step is I would switch on the test pulse. Yeah, so you switch on the test pulse by pressing on it. And in this case, a double test pulse is being displayed. If you don't like a double test pulse, you can change it. You can change it for a single test pulse, for example. Me personally, I like single test pulse better. There's no difference for the Patchmaster. The algorithm works with either one. But for example, I also like, instead of a positive test step, I would like to have a negative test step. Reason being is that when you step in positive directions, you never know if you might step into an area where voltage activated stuff happens. So you don't want to do this really. So a negative test step might be better. And this is where you selected the amplitude. And if the test step is too short or not long enough, if you want to change the length, basically, you select this box, and let's say we double it. We set it to 20 milliseconds. And then the last thing here in the test pulse window, as you can see on the right-hand side, we have the voltage step being displayed in red and the current response to that step being displayed in black. To change this display, what we can do is we can select if we want to have either one. The current response, definitely, we need to see that. So that should be selected for sure. And if you click on current, then only the current response is being displayed. Again, this doesn't matter for the outcome it's basically what you like to have displayed. Okay, and now the final thing, if you don't like the size of it, if you want to have a bigger current response, you go to gain, you click on gain, and again this drop-down window opens up. And now please note that every time you move your mouse pointer, I do not engage it. Every time you move it, there will be a preview on the right-hand side. Okay, so this preview is basically what would happen if you engage this gain. Okay, so and as you can see, if you would go, for example, to 20 millivolts per picoamp, that might not be such a good idea in this case because you already saturate the amplifier. So let's go to 10. That's also a little bit too. Let's go to 5. That seems to be just fine. Okay, and now you can engage it, and this gain is set. And now I would go and try to establish the seal to the cell. We can easily demonstrate this here or simulate it by switching the model cell to the middle position. And then you see the transients are being displayed, which is basically the simulated pipette capacitance. To compensate for those, you press this little auto button here. And that's it. Now you could go on if you want. I personally would like to, before I break into the cell or before I establish the whole cell recording configuration, I would recommend to set the membrane potential already to the value that you expect or that you want to clamp your cell to. In this case, I chose minus 60 millivolts. And now I go on and try to establish the recording configuration, which is the whole cell configuration. In this case, it's very easy. I just switch to the third position of the model cell, and then I have the whole cell recording configuration simulated. Now, manually, what do we do now? We first have to basically address the size of the cell. And this is done here with range. You click on range, drop-down window opens up, and you should specify now the maximum size of the cell that you expect the cell to be. Be on the safe side. Bigger is better than too small. If it's too small, if you select the range too small, the automation of compensating for the cell capacitance and the serial resistance might not work correctly. So you better err on the side of being too big. Yeah. So in this case, I would say, let's say, put it to 100 picofarad. In most cases, this should be sufficient. Then all you need to do to compensate or to neutralize, I have to say, the cell capacitance and the serial resistance, you press the auto button. That's it. And now you can get started on your recordings if you want to. If you're doing recordings in terms of voltage steps or voltage ramps, and you have a bigger current amplitude, or you expect a bigger current amplitude than, let's say, 200-300 picoamps, then I would strongly recommend to compensate for the serial resistance error. And you do that by using these controls down here. Again, the first thing you do is you select the speed of the compensation. And here it is important to note that the faster it is, the more dangerous it will be that you put your system into oscillations. So for most people, 100 microseconds speed is perfectly fine. Then you press the auto button, and that automatically compensates the serial resistance to a level that is safe, that is definitely not causing any oscillations. In this case, 47% of the error has been compensated. Most people like to actually set this to 80%, which is no problem. You can do that. Yeah? Just make sure that you don't create any oscillations. And now you would be ready to do your experiments. Before we do that, I want to show you how to do the whole thing now with those auto buttons. Okay? To do this, I go back and basically set everything back to the beginning so that everything is like it was in the beginning when we started the whole process. So this is 0, this is 0, this was 0, this was 0. We didn't have any junction potential. We had an amplitude of the test pulse that was 10, and this was set to both. This was set to double and off, and and this one we set to 0 millivolts. Okay, so this was basically at the beginning when we started, and now we would like to use the auto buttons. And while I'm using the auto buttons, I want to modify them to whatever was the setting that I actually liked. Yeah, and we do that with the protocol editor. So before we start, we have to now adjust the protocols that will be called up on when you press the auto buttons: the open pip, the cell attach patch or seal, and the wholesale. And to change the protocols, we press on F9 to open up the protocol editor. Now here you see, this is the protocol open pip that would be executed when you press open pip, this button over here. And you see what it does is, it makes sure that the mode, the recording mode, is set to wholesale. It will set the gain to 5 millivolts per picoamps, and then it will press this little auto button over here, this offset auto button, auto 0. Yeah. Now, like I said before, I would like to, before I press auto 0 button, I would like to include my liquid junction potential. Now I can do this manually by entering the liquid junction potential manually before I press the open pip button, or I can, if it's always the same, include it in the protocol. And that's what I want to do now. Let's assume it is always the same. So let's include it into the protocol. And like I said, it should happen before this command. So I'm selecting this command, and then I say insert before. Now I do not talk about any other commands other than the macro command now. The macro command gives you now access to changing the settings in the amplifier window. And I want to have this little, this command should change the liquid junction potential to -5 millivolts. And to do this, this is how easy it is, really. You basically now create a macro. You start recording what you would do, or what you want this command to do. You show it, basically. And you do this by record macro. Now the next thing is basically only the steps that you want this command to execute. So the first thing would be you select the box, you enter the value that you would like it to have, you press enter, and then you press stop recording, and this is the command that would enter -5 millivolts into this box. Yeah? I can reset this now again to 0, just to make sure that you will see in a minute that this will all be done automatically. Okay, the next step that I said what we would like it to do is, after the auto button is pressed, I want to establish a test pulse so that I see when I approach the cell. And I can do this also automatically. So let's go again back to my auto 0 button. This is the command that will execute this button, and after it I want to now do the test pulse settings. So I'm going to insert after, click on macro command, click on recording macro, and now I basically do what I would do or what I did before manually. I basically teach the protocol editor this command. And what I'm doing is I'm first setting this to single. Then I set the amplitude to -10. I set the length to 20 milliseconds. Always pressing enter to make the computer accept it. And this I set to current only. And then I stop the recording. Now it entered all those commands into the protocol script. And to show you that it will do this later automatically, I reset it now manually to the former settings that it had, so that you will see that it will be done automatically when we do the actual automation. Okay, so this is all set back to where it was before. Now, with the Cell Attached Patch button, or this button over here, basically, when I press this button, the protocol Cell Attached Patch will be executed. And you see at the moment, all this button does, it will press the Auto See Fast button, which is this one over here. And this is fine. This is fine. When I have a Cell Attached Patch configuration established, or a seal to the cell, I want to, of course, compensate the pipette capacitance. And this is done by pressing this button. But remember, afterwards, before we go on and establish the wholesale recording configuration, I want actually to set the membrane potential to -60. And this is, again, something I can do automatically. So now I'm selecting this command, and after that, insert after, macro command, record, -60, pressing enter, yeah, and stop recording. So now it will do the following. After this command, Auto See Fast, it will establish a -60 millivolt membrane potential, and then I go on and establish the wholesale recording configuration. The wholesale button does more stuff. You see, when you press the wholesale button over here, all this stuff will be executed, which is fine by now. I didn't make any big changes to whatever it does automatically already. Now I'm closing this, and that will enable the changes into the protocol editor file. Okay. Yeah, now I basically can do exactly what I did before manually. I can do now by using those buttons up here. So let's get started. Let's assume I have a pipette into the bath. The pipette is still open. The tip is still open. It is hovering above the cell. Now I want to compensate all the offsets. And what I have to do, I press this button. As you can see, it established a -5 millivolt liquid-liquid junction potential automatically. Then it pressed the auto button. And I can see that it did it after putting this in, that it took the -5 millivolts into account. Okay? Then it switched on the test pulse, but it set it to single. It set -10 millivolts instead of +10 millivolts, set the length to 20 milliseconds, and set current only as display. So it did all the stuff automatically that I wanted it to do. Now I'm establishing the seal, or the Cell Attached Patch configuration, by switching the model cell to the middle position. And then all I need to do here is press the cap button or the seal button. And as you can see, everything is done automatically. It compensated the cell, the pipette capacitance, and set the membrane potential to -60 millivolt. And now I'm establishing the recording configuration, the wholesale recording configuration, by switching the model cell to the third position. And all I need to do now is press the wholesale button. As you can see, everything is done automatically. It also set the compensation automatically. I did not make the 80% down here automatic. This is something you should only do manually, in my opinion, because you want to make sure that in this specific recording configuration that you now just established, that it is good enough to allow you to compensate 80%. So you should have a look at it before you actually go here and set this to 80. Okay, that's it. Now we can get started with the recording. Now let's do a recording. Okay, before we do recording, as you can see on the right hand side, the replay window is still dark, which means we did not create a data file yet. We need to create a data file where the recordings can be written to. And we do this by going over here to File, press on New. This will open up a dialog where you now can give it a name. And today is the 6th of April, so we basically, I like to give it basically the name of the date. And we say Save. That will create a data file in which we can now write the data to. Okay? And here comes the thing that I mentioned in the beginning. Look, we have a name for the data file, a label. This cannot be changed, but we can add something to this. It's highlighted right now. Yeah, when you click on it, it highlights it. Highlighted is in light blue. And now we can press on text and we can enter any text we want, a whole paragraph if you want. I would use this feature to explain to yourself basically why you did these experiments, what you want to do, basically your project. And later on, weeks, months, years from now, you can open the data file, click on the data, look at the root text and know exactly why you did it, what reason was behind it or whatever. Yeah. In this case, these are recordings that are basically done for demonstration. Demo recordings. Done. This is now linked to it. And every time you click on it, you select text, this comes up and you see what it done. It can be, of course, edited if you want to. Now, the next button is basically, or the next area, or the next level, I should call it, is the group level or the cell level. I like to give, and here you can change the label if you want. So you can, basically what's written here, you can change. I like to basically call it the cell that you're recording. Let's say it's a pyramidal cell, I would call it pyramidal cell or something. In this case, we are recording an MC10. That's the model cell. And if you want to explain it a little more than just the label, it's maybe not enough text or space to explain what kind of cell it is, what kind of animal, the age of the animal, all these things you can put in here if you want. You basically put text. And now you can also link a text to this if you want. Yeah. And in this case, we can call it, it's the model cell of the EPC10 USB amplifier. Yeah, and then you can say done, and it saves it to this specific cell. And now we can do some recordings. The first thing what we need to do is, of course, we need to create a stimulation file. So we open up the pulse generator, and here we have already a step protocol being selected, and no other protocols have been made yet. So we can use the step protocol. And I want to demonstrate quickly a couple of things that you can change here now and where to change them. For example, the number of sweeps or steps can be changed here. You can set it to 12 if you want to have 2 extra steps or two more steps. So the acquisition frequency is basically shown here. So what you can do is you select it and you basically left click and hold down the button. It gives you the possibility to scroll to the correct frequency if you want to. Or you can enter, of course, the sample interval time. That would also set the frequency. I want to reduce it a little bit. It's 20 kilohertz is kind of fast, so I set it to 10 kilohertz. Underneath it is the stimulation area where you can select the stimulation channel, the DA, digital analog channel. And you click on it, and here you can select all kinds of channels. StimDA is the standard channels that we want to use. Then on the right-hand side, we have the channels that are being recorded. IMON2 is the standard channel for the current response, so we leave that, of course. And underneath it is the channel for the step protocol, basically the voltage trace. And you can change it to anything you want, or you can leave it. You can add more channels by clicking on a box and changing the setting here. Or you can, of course, select whatever is selected here. you see it's the VMon, and you can change it if you want to anything you want, or you can also switch it off if you don't need it. Make sure that the store button is selected. And then we look at the step protocol itself. And here we have a step protocol that is made out of 3 segments. The first segment is basically the holding current, the holding potential is being displayed. You can of course change it to value and enter any value that you would like to. I'm okay with the holding potential, which is at the moment up here. You can see it minus 60 millivolts. So I leave it at the holding membrane potential. And it steps to that potential for 10 milliseconds. And this is the first segment. And then the second segment is really the one that is interesting, because here you step now to different test steps, different test potentials. Now we could, for example, say the first step you want to do is not to minus 60. Let's say we want to step to minus 80 millivolts. And the duration of the step is not 50. Let's set it to maybe 100 milliseconds. And here, down here, you say that the next step should increase by 10 millivolts. This can also be changed. You can change it to decrease, for example, make it smaller the next step. We leave it on increase now. And then maybe the step size is 10 millivolts. Let's set it to 15 millivolts. So the step size itself is 15 millivolts. And then the last segment again is the same like the first one. I just want to have it to see basically what happens at the end when we are done with our steps. So I just leave it like it is for now at the holding potential for 10 milliseconds. Okay, this is enough now to get started. And one other thing here, you see that we linked the online analysis to this step protocol. Okay, and I leave the link in place, but I want to make sure that no analysis is being done at this moment. So what I'm going to do is I'm closing the pulse generator, which enables all the settings that we just made. I'm opening the online analysis and making sure that up here it says no analysis. Okay, this is now selected. It says no analysis in the online analysis window. Therefore, no analysis will be performed at this moment. I close this. Now, all I need to do really is press this button down here to get started. And as you can see, the store button is enabled, so we should actually record our data. I'm pressing the button, and as you can see, the data are being displayed. And I can also click over here and see that all my data have been recorded. And to see those data a little better, I can press on Auto Sweep, and on selecting the whole trace, I can repaint, and you see the whole data are being displayed here. While we are at it, we can explain a little bit about the oscilloscope window. For example, this button here, it says DIG filter, which means it's the digital filter that can be applied to the data. It will not change your raw data trace. It will only be basically applied to your displayed data, okay? Not to the raw data trace. Okay, and this is some button you left click and hold, and then you scroll, and while you're scrolling to different filter frequency, the preview shows you what would happen if you engage it, which is of course very nice to get an exact data frequency that you would like to have. Yeah, and then you can say repaint, and it shows you the whole data trace again. So this is a very nice feature. Now what we can do, of course, is we can now, let's say we would like to do the analysis, and for doing that we basically selecting again the online analysis. I'm also opening just for display purposes now, so that you see the link nicer next to each other basically. This is the pulse generator window with the link to the online analysis. Okay, and now I can enable this online analysis that I already created earlier. Can go to analysis and say auto stimulation control pool. So it will look into the pool to find the analysis that is being specified down here in the link. Yeah, these names have to match. And then it will automatically execute this analysis over here. But one more thing. You need to tell the link which segment here has to be analyzed. Okay, so in this case it's segment number 2, of course, because we are interested in the different steps. So we are selecting segment number 2. And this is now the segment that will be analyzed. What kind of analysis will be done? Let's close the pulse generator window again so that we focus only on our analysis for now. This is the functions that are being done. So at the moment, this function, which I called steps, it measures the amplitude. And I will go into these little things in a minute when we create actually a new stimulus file and a new analysis file. But just for now, so that you know already in what we're going to do, if you, for example, would like to change the functions in an existing method, you go to the function, you select the function like this, you press on change. This will open up a window that gives you now the possibility to select a different function, which I will not do now. But you could, for example, go instead of amplitude, you would like to measure the duration. So, okay, I leave it like it is for now. The same is true for the mean. I call it I mean or current mean amplitude. Yeah, and you can see already it is linked to this function, and I could change it if I want in the measurement part. I could measure something else, like the maximum instead of the mean could be measured. For now, I leave it like it is, just for demonstration purposes. I'll show you in a second. So both of those functions, yeah, measure, of course, or are linked to this step protocol here. And this down here basically specifies the input and the output. So we are going to record the output in the notebook because it is selected. And we are recording the steps as well as, let's see, the mean. Yes, it's also selected. Yeah, so we can do that. And then we display this on in a graph. And we're going to look at graph window number 1. Okay. Or actually, you know what? Leave this open. I just put it over here so that you can always look back and forth between those. And what I'm going to open now is the analysis window number 1. Because this is the window that will display our analysis. Okay, so move it over here. And to get a better view of what's going on in the notebook, you could, if you, for example, would like to save whatever goes on in the notebook now, before you delete whatever is here, if you want to save this stuff, you can actually do this by selecting the notebook and going on Save As, for example. You could save whatever is in the notebook. You can clear it and you can do other stuff as well to the notebook. This notebook will always be completely cleared if you press Control B. Yeah, that deletes everything in the notebook, just that you know. Okay, now we do this same step protocol again, like before. But this time, we don't really need to record it. The online analysis will work with or without recording the data. Just for demonstration purposes, I actually now do not record it. So I'm clicking on Store and disabling the recording feature. The online analysis will still work. If I click now on IV, as you can see, while you're doing the recording, the analysis is being done. Plus, look down here, you see that the steps are being recorded as well as the I mean, and you can easily export it as I showed to you before with a text file and can get it into a third-party analysis if you would like to. Yeah, or of course also in FitMaster, that would work too. You can of course also use those values now to do more analysis in PATCHMASTER, which I will not go into detail now. But this is, for example, something. And if you now would go, for example, over here in the online analysis window, you're selecting steps, and you decide I don't need the notebook, you can unhook it. Yeah. When you close it, this changes will be enabled. And if you now run this whole thing again, you see, now the steps are gone. The analysis is still being performed completely like before, but the steps are being not recorded anymore in the notebook. So these are the things that you can, for example, do back and forth in those things. Here is now what I mentioned before. Another alarm bell should go off in your head if you see in your replay window that there's this little hashtag. This little hashtag is for you to see, oops, these data have not been recorded and cannot be recorded anymore. This is just for you to remember, oops, yeah, okay, the store button was not enabled. So I enable the store button and then I press IV. And now you can see data are being recorded. Okay, this brings me almost to the end of this whole presentation, but I would like to show you quickly how to create a stimulus sequence, how to do an online analysis with that newly created stimulus sequence. So first stimulus sequence, let's open the pulse generator for that. And let's say we would like to create a ramp protocol. So we are selecting the next free spot, and this opens the name. So we can call it basically ramp. Yeah. Okay. And now a ramp is usually only one sweep, so I leave it like it is, one sweep. Again, I do not like the speed of the acquisition. I think 10 kilohertz should be fine for this. The stimulation channel is fine. The recording channel is okay. And now I can create the ramp here. To do this, I first have to specify basically the different segments that make up the ramp. The first segment is basically my holding segment that I'm working with. And I can say again 10 millivolt, holding potential, which is at the moment minus 60 millivolts, and for 10 milliseconds. And then the next step would be, again, I have to enable it by, or making it available, this segment, by selecting stored, okay? And then I want to step to a value, and that value, let's say, is minus 80 millivolts. Now, at the moment, it steps down to minus 80 millivolts for 10 milliseconds, which is not what I really want. It should only step down to minus 80 millivolts and then get started with the ramp right away. So I'm setting this to 0. Okay. After that, after this step to minus 80 millivolts, now comes the ramp. Again, stored enables the segment. It's not a constant where it should go to, it's a ramp. And the ramp value from where it should go to, let's say it's 100 millivolts. And the length of the ramp, we can put it, let's say 200 milliseconds. Okay. You see, every time you press enter, these values are being taken into account and the little cartoon is being updated. Okay. Now, after being at plus 100 millivolts at the end of the ramp, I wanted to step back to the holding potential. And for 10 milliseconds, just so that I can see what happens here at the end when we step back. To make this little cartoon fit my actual whole situation, I can give it also, I can tell the cartoon where my holding potential is. This setting, what I'm doing here now, has no effect whatsoever on the amplifier. Okay, that's why it says display. Whatever is done here is purely cosmetic, just so that my ramp and cartoon is exactly like it's in real. Okay, now I've done the ramp and I can actually already execute it. I can close this. As you see down here, automatically there has been a new stimulation sequence being created. Okay, and if I click on it, it executes the ramp. And I can say again auto sweep, and this shows me the whole ramp. Plus, it of course shows it up here. The ramp is the third sequence that we saved, and it shows it right here. Okay. Now I want to link this ramp to an online analysis. Now, as you know, a ramp is a current response against time. But what we really are interested in is the current response against the specific potential that is at that moment or that caused that current response. So to create basically an IV curve of the ramp protocol, we can link it to an analysis and create both at the same time, the raw data and the IV curve. And how is that done? Now, first thing is you open up again an online analysis. So let's move it over here so that we see it. And we want to create now a new method. So we're selecting method. And we can call it anything we want. Let's call it, for easy terms now, ramp. Okay. it will ask you, the program, if you want to copy any previous settings. For this, no, we start from scratch. Now the first setting that we're going to choose here is a function where we basically tell the computer that we would like to know the stimulus, which is the potential, of course. So we say the stimulus for the trace. The stimulus of the trace is what we want to have on one side of the graph, on the x-axis, basically, which we will determine in a minute. Yeah. So stimulus, we say done. Okay. And now we can also, instead of stimulus, give it a different name. We can say this is the voltage, and the whole thing is in millivolts. Okay, this gives us a better idea. When you have many of those functions lined up and there are 5 stimulus, then at some point you don't remember anymore what is what. And so you better give it a nice name that you can remember what it is. In addition to this, we want to have, of course, trace number 1. Yeah, over here you see trace number 1. So trace number 1 is being analyzed. And we want to set this to segment, because this gives me the option for ramps only. So we only want the ramp be analyzed. So we say ramps only. Okay, then the y-axis or function that we want to have displayed in the graph is, of course, the trace itself. So we want to have the current response of the trace. So we say trace. Again, trace number 1 of what is the trace? It's the current. Again, I would definitely rename the stuff so that you can remember later on what is it what I'm looking at. So it's the current. Yeah, trace number 1 again over here, trace number 1. So that's clear. And here again also segment, so that we can say ramps only. This now is all what is to it for the analysis. Okay, so the analysis is being defined that way. Now we have to tell the analysis how it is being displayed. And this is done here in the analysis graphs. So we go to off and switch on the first graph so that we have a graph to work with. Okay, I don't go into details now into cosmetics, how you could change the scaling and all this stuff. The tick size and all these little things, you know, you figure that out yourself. So you can leave this, I leave it for that for now. All I'm doing now is selecting one graph, and here I can tell now what the graph should display. So the x-axis already shows voltage, which is okay. The y-axis I set to current. And now I can also press this little yellow button underneath, which would give me a chance to change whatever display features the graph should have. I want to make it little points and very small so that it looks like a real trace basically, and not like an IV plot with big symbols. Okay, so that's done. And on this side here on the bottom, I now tell him to be displayed in graph number 1. And graph window number 1, which is the analysis window number 1. Okay, now I can basically close this, or actually before I close it, I should leave it open so that you see in a minute also how I still have to link it. Because as you remember, the ramp protocol is selected, so this is the ramp protocol that we want to execute, but we haven't linked it yet. So you need to link it to this ramp method. Okay, all you do is basically you give it the correct name. The correct name, it has to be matching. So this is ramp and ramp. So this should match nicely. And now you have to tell it also which of the segments is the relevant segment that has to be analyzed. And this is segment number 3, of course. So I'm telling it number 3 for X and Y. Then I close this. And I close this. And let's open the online analysis window, number 1. Okay. Okay. And now I can either record again or not record. It doesn't matter. The analysis will be done. Let's not record it for now. And press ramp. Done. Okay. So here you see basically the IV plot of this response. Now, there's one thing before we finish here. I want to quickly show you that little changes in settings can have effects on your display and on basically cosmetics that I'm showing you now. For example, the program wants to make sure that it gets the whole ramp. So a couple of recording points before the ramp starts, the program already gets started, as well as at the end. Yeah. So to get rid of these kind of not so nice looking beginning and end, you can change things in the step protocol itself. And for example, if you open the protocol editor, you can, instead of no time at all in the step from holding potential to -80, basically this front part here, you can say step there for 2 milliseconds. Yeah, so now there's a very small little time where the amplifier steps to this -80 before the ramp starts. The same is true on this side. I can actually tell them to go to the value of 100 millivolts for 2 milliseconds. Yeah, and then step back to the holding. Now you can see that after the ramp, there's a 2 milliseconds waiting before we step back. And this will allow now the program to really find the beginning and the end of the ramp precisely. Okay? Anything else I leave alone. It's still segment number 3 that is being analyzed. Okay, so, and this we close. And if we now run the ramp again, it looks much nicer. Okay, so here it is. The ramp has now very nice definitions at the beginning and end. Now these are little things, not really that super important, but it should give you an idea already of how complex the program can be and how you actually can use it in many different ways. Now to finish this whole demonstration, I want to quickly show you how easy it is to get out now some kind of data. For example, if you would be interested to get this data trace out, you would make sure that the oscilloscope is in the front. Then you go on replay, you select export, then it will export what you see, or you can export full sweep, and it will export what the whole sweep, no matter what you are looking at right now. Important to note here is that the format has to be, of course, in a WMF format, which is a picture format. So you would get a picture out of this. Now, I personally like to, rather than going with picture export and then picture import and all this stuff, just select what you want. Let's say you would like to get this part out of your ramp. This is the part that you would like to show. And all you need to do now is make sure it's in the foreground. And then you say Control C, which copies the oscilloscope. And then you need some kind of program. For example, I'm using now OpenOffice. And then you say Control V, and that brings you your trace in here. And of course, you know then what to do. You can, with right click, break apart, and then you can delete things that you don't want to be displayed. And so you can basically do this. Of course, you can also then take a part of your trace and then right click and group it again. And then this part of the trace would be the one that you can now copy paste, for example, in PowerPoint. And this works, of course, as well with the analysis trace. You basically have to highlight this, copy paste it, and bring it in. So this basically concludes the live demonstration for now. My name is Frank Elsen, and thank you for your attention, and I'm looking forward to hear more from you. Thank you.
Thank you, Frank, for your time today. To the viewers, we hope you found this presentation both informative and useful. Of course, we invite you to contact us using the email or the number shown below should you want further discussion regarding PATCHMASTER or the HEKA products. Thank you for your time today, and we hope you have a wonderful day.